Logarithm. Law 1. The first principle of logarithm says if you have a logarithm like log AB base C, very important. What it means, it can be re-expressed as log A base C plus log B base C. The bases are very important, very key. It could go both ways. It could be reversed to this side, it could be reversed to this side. But basically the first law says if a logarithm is expressed to the same base and is expressed in form of two different integers, in which case like we have A and B are separate integers but are multiplied. AB means A dot B or A product B, which is A times B. Now if you have this kind of expression, what you do is you can add the separate logarithms. That's the first law. The second law, the second principle says it's just like we have in indices. If you divide A by B to the base of C, it means you should have log A base C minus log B base C. And if it was this one I first wrote, it also means this one. So if I had written log A base C minus log B base C, it can be re-expressed in this format. And if I'm giving you like this, it can be expressed in this format. Let me give you an example. If for instance I say log 12 base 3 minus log 4 base 3. According to this second law, it can be re-expressed like this as log to the base of 3, 12 divided by 4. And from ordinary maths, 12 divided by 4 is 3. So we have log 3 base 3. So the second law says when you are dividing numbers and it's to the same base, it can be further expressed like this. If you have it in this format originally, as in this example that I gave, log 12 base 3 minus log 4 base 3, it can be expressed as log 12 divided by 4 base 3, which again can be written as log 3 base 3. This one also can be further expressed, it will give us 1, but I have not shared the principle with us. But the final answer here will be 1. Log 3 base 3 is 1. Now the third principle. The third principle says when you are given an initial logarithm, law 3. If you are given a question of the format log m raised to power n base x, this can be further re-expressed as n log m base x. If you are given this kind of question, in which case the number of the logarithm has an index, the index can be transferred to the back of the logarithm. Let me give you an example. Let's say for instance I give you a question like this: log 64 base 4, and I ask you to simplify this. 64 can be expressed in indices format, in which case you could say log 64 is the same thing as 4 raised to power 3, still to base 4. This can be expressed like, according to this law, can be re-expressed as 3 log 4 base 4. And again, log 4 base 4, like I already shared with us here, becomes 1. So the final answer here will be 3 times 1, which again is 3. So that is the third principle. The fourth principle, just like we have in indices we said any number raised to power 0 is 1. The fourth law in logarithm says log 1 to any base. Log 1 to any base is equal to 0. The logarithm of 1 to whatever the base 30, base 50, log 1, base 12, log 1, base 3, log 1, base 4. Whatever it is the base, if it is log 1, then the answer is 0. The fifth principle for logarithm: log of a number to the same base. Log of a number to its own base. Log m base m is equal also to log k base k. Is the same thing also as log 5 base 5. All of them are equal to 1. This law says if a logarithm is expressed to the same base, just like in the examples I've given here, log 3 base 3, log 4 base 4, all of them are equal to 1. Log 4 base 4, log 12 base 12, log 9 base 9, all of them are equal to 1. It's important you also master these principles. The sixth law. The sixth law, it means it's a way of expressing. It's a way of expressing what has already been given to you. Law 6. It says log b base a can be written as log b over log a. So if I give you a question like log 5 base 2, it can be written as log 5 over log 2. It can be re-expressed as log 5 over log 2. Alright? Let me give you a practical example on that. There are several ways to address questions that come in indices. Using this sixth law, if I give you a question as log 8 base 2, this particular question can be addressed in two different ways. We could express it as log 2 raised to power 3 base 2. Then this one becomes 3 log 2 base 2, which again becomes 3 times 1. Otherwise, you can rewrite log 8 base 2 as log 8 over log 2. Again, log 8 can be expressed as log 2 raised to power 3 over log 2. Again, this is written as 3 log 2 over log 2. Then log 2 cancel each other, then you have your final answer as 3, just like you have in using this same this method. So if you understand the way it works, it becomes a lot cheaper. It becomes very, very cheap. So these are the basic principles that guide operations in logarithm. These are the basic laws. Now let's take some practical examples and let's see how some of these laws, some of those principles are weaved together to produce answers. They are weaved into questions so that you can see how to manipulate them when you meet them in standard exams or international exams, or even when you go for aptitude tests. I discovered that many of the times, especially in the university, I did a master's recently, and I discovered that many of the people who come for master's programs are those who have left the secondary school for 20 years. This kind of material will assist you. It will serve as a refresher course. So some of the people who would like to jog their memory, to remind themselves of things they've learned 20 years ago, I believe this will serve as a very, very good tool in reacquainting you with some of the things you've learned several years back. So let's take some examples and let's see how we can apply some of these things we've learned when we are faced with such questions. Log 98 base 7 minus log 30 base 7 plus log 15 base 7. When you're faced with this kind of question, the first thing that comes to your mind is you must understand that you have to deal with BODMAS. What is BODMAS? BODMAS is a law that guides operations in mathematics, and you cannot answer some questions except you obey the principle of BODMAS. What is BODMAS? B stands for bracket, O stands for off, D stands for division, M stands for multiplication, A stands for addition, and S stands for subtraction. This question can be re-expressed or can be rewritten such that it will be easier for you to obey the law of BODMAS. Log 98 base 7 plus log 15 base 7 minus log 30 base 7. What I've just done is I brought this one to the front and I have taken minus log 30 base 7 to the back. What then you do the next is you apply the first and the second laws. Apply the first and the second laws, which says when you are adding, you multiply the values. When you are subtracting, you divide it. So you have log to base 7 outside, open a bracket, you have 98 times 15 divided by 30. 98 times 15 divided by 30. If you do that, you have 15 here 1, 15 here 2. 15 will go in 30 twice. And then you can also use 2 here 1 to divide 98. You will have 49. So invariably you have log 49 base 7. And of course, some of the laws, one of the laws we consider today says that if you look at the number you have here and it can be further simplified, like in this case 49 is a perfect square, just like 16 and 25. 49 then can be expressed as log 7 raised to power 2 base 7. Again, log 7 raised to power 2 base 7 can be rewritten as 2 log 7 base 7. And like one of the laws we have considered today says, logarithm of the number to the same base is equal to 1. Then you have 2 times 1, which gives us 2. This is a combination of about 3 or 4 laws put together. So it's important that you understand the application of all of these principles put together. You understand the application of all of these principles put together. Let's see a second one. This one is a fractional number, like we have here 98, 30, and 15. All of these are integers. But what if the question did not come in that format? What if you were given questions like the ones I'm about to put on the board? If you are given log 3 over 8 base 5 plus 2 log 4 over 5 base 5, again minus log 2 over 5 base 5. If you are given this kind of question, how would you answer it? What are the basic things that you bring to play? What are the things you will do to answer this question? Just like we did for the formal example, this example 2. When you are adding, you multiply. When you are subtracting, you divide. So we can take logarithm to the base of 5 outside, and then you open a big bracket, so you have 3. But before we do that, you will notice that log 4 over 5 base 5 has a coefficient. So for all of them to be in the same class, it's good that you take this coefficient back as an index of 4 over 5. So log 3 over 8 base 5 can be expressed this same way, but this one can be written as 4 over 5 raised to power 2. These two will return it back as an index, still to base 5, then minus log 2 over 5 base 5. Then you apply the law that says when you are adding, you multiply, when you are subtracting, you divide. So we have log 5. Open a big bracket, you have 3 over 8 times 4 over 5 squared divided by 2 over 5. Again, you move on to the next step. The log 5 is still outside. Then you have 3 over 8 times 4 over 5 times 4 over 5 divided by 2 over 5. Again, from your knowledge of fractions, you know that when you are dividing by a fraction, if you must change the sign division to multiplication, you will invert the fraction. So the next line we are going to write is still log 5 is still outside. We have 3 over 8 times 4 over 5 times 4 over 5 times 5 over 2. Reason why we have inverted it is because we have changed this division sign, we have changed it to multiplication. So now we can cut out the similar ones. 5 here will go in 5, 4 will have 2, and then we have the others left. So we have still log 5, then you have 3 times 8, 2 will go in 8, 4 will go in 4, 1. So we have log 3 over 5 to base 5. Log 3 over 5 to base 5. And the question says simplify. It says simplify given that log 3 over 5 base 5 is equal to 0.682 is equal to 0.682. All right, so see that if you have gotten it up to this point, log 3 over 5 base 5 is what you have gotten, and you have been given this value, the whole of this value as 0.682. So your final answer therefore will be 0.682. 0.682. Now this is another example under logarithm that has weaved so many of the questions together. I will take another example and then we'll go into use of logarithm tables. Take another example which is going to be our third example, and then we will move further in our study of logarithm. The good part of this kind of material is you can pause, you can press slow, again you can rewind and listen to it again and again. So you do not bother to see whether we are playing it. You have the capacity to replay it again and again. Now the third question is 3 log 2 plus log 20 minus log 1.6. Now, like I said, if you look at these 3 logarithm numbers, you will discover that this one is not the same thing as these 2. The reason being that this one has a coefficient. The coefficient here is 3. So you must express all of them in the same manner. So this one must be re-expressed like this. To re-express 3 log 2, it will be log 2 raised to power 3 plus log 20 minus log 1.6. Again, you have 2 raised to power 3 is log 8 plus log 20 minus log 1.6. Again, one of the laws of logarithm says when you are adding, you multiply. When you are subtracting, you divide. So we have the log, the base was not specified. So we have 8 times 20 divided by 1.6. And then you can express this decimal in fractions. Again, this can be re-expressed as logarithm of 8 over 1 times 20 over 1 divided by 1.6 can be written as 16 over 10. To change this division sign to multiplication, you reverse the fraction, just like we have done in one of the examples. So we have 8 over 1 times 20 over 1 times 10 over 16. So you have 8 here 1, 8 in 16, 2. 2 here 1, 2 in 10, 2 in 20, 10. So you now have log of 10 times 10, 10 times 10. 8 has gone in 16 to 2 has gone in 20, 10. So we have 10 times 10, which will give us log 100. Again, I need to let you know that anytime this is not, the logarithm is not expressed, anytime the logarithm is not expressed to a base, know for a certainty that the base is 10, except otherwise stated. You must understand, anytime the base is not given, the base of that logarithm is 10. So this one, it can be expressed as log 10 raised to power 2, which again is the same thing as 2 log 10. And then log 10 to base 10 is 1. So the final answer is 2 times 1, which is equal to 2. So these are the examples which you can play over and over again to understand how to handle questions on logarithm. Still dealing with under logarithm is the use of logarithm tables, and here we'll be dealing with numbers of logarithms that are greater than 1. Numbers can be manipulated using the logarithm tables. As a matter of fact, during my days in the secondary schools, we were not allowed to use the calculator. What we used even for the WAEC exam was logarithm tables, something like this. So it's good that you understand in a situation where you find yourself and you press your calculator and it's not working, you can make use of your 4-figure table to answer some questions. Here we'll be dealing with numbers that are greater than 1. The two most important table in this 4-figure table, for at least especially for this, is the logarithm and the anti-logarithm tables. Logarithm of numbers and anti-logarithm. This page is anti-logarithm, this page is logarithm. I'm sure you have something like this. You can buy it, I think it's about 200 naira from WAEC office in Yaba. The number and the tables are divided into two parts: the numbers and the differences. Before you can look at a table at all, you must first express your given numbers in standard form. That was why before we got to this stage, I already explained to us what it means to express a number in standard form. I said it's a way of expressing a number in a compact form or in an economical form. So you must first of all express the number in standard form before you can go to your table, either the logarithm or an anti-logarithm table, to use it. So let's take an example. Look at this question. If you are asked to evaluate, the question says evaluate 7820 times 5.05 divided by 944 times 11.7. The step 1, like I've already shared with us, is express all numbers in standard form. You may need to rewind back so that you know how we do this. So this one becomes 7.82 times 10 raised to power 3. You shift it from here, 1, 2, 3. The second one is already expressed in standard form, so you don't need to change anything there. The third one, 944, is expressed as 9.44 times 10 raised to power 2. And again, the last numbers, 11.7, is expressed as 1.17 times 10 raised to power 1. Now, this is the first stage. Then the second step, let me clean this. The second step is you create two columns. One will be for the numbers, the other one will be for the logarithm. When you check your logarithm tables, whatever it is you determine is what you will put on this side. So let's take the first one, which has already been expressed in standard form. 20 times 10 raised to power 3. The reason why we ask students to express, or why it is required for you to express your numbers, the given numbers in standard form, is because of the first number that you put on this part. That first number before you go to your table is the power or the index of 10. Let me repeat that. If you are asked to evaluate this type of number using the logarithm tables, evaluate using the log tables, you will need to express all of these numbers in standard form. And then the first number, the first digit you write here must be the power of the 10, the power of the 10, the power to which the 10 is raised. That will be the first digit on this side. It could be negative, it could be positive. If it is negative, it is written as bar 2 or bar 3, whatever the number here is. But if you look at this question, this power here is not negative, it's positive. So you just write the 3 there without putting any sign on top of it. Then you put a point. Then you look at logarithm of numbers. If you have this table, is on page 2. You look at 78 under 2 difference 0. 78 under 2 difference 0. 78 under 2 difference 0. If you have that, the 78 is on this side. 78 under 2, you will see these ones 0 to 9, they are the ones for the third digit. Then the last digit is for the differences. X is for the first 2 digits. The third digit is for these numbers 1 to 9. and then the last or the fourth digit is usually for this. Now 78 under 2, according to my own table, which I think is the same thing with yours, is 89.32. The second one, 5.05, is 0.733. Since there is a division sign, and of course you know in logarithm, when you are multiplying you add, when you are dividing you subtract. So for this, first for the numerator, to determine the value of that, you will add the values together. This one is 50 under 5. If you look at your log tables, look at 50 under 5, you will get 0.7033. If you look at 78 under 2, difference 0, there's no difference here, there's no difference here too, you will get 89.32. So then you add the two of them together. So this one becomes 6, 5, 3 plus 2, 5, 3 plus 3, 6, 9 plus 0, 9, 8 plus 7, 15, write 5, carry 1, 3 plus 0, 3 plus that one, you have 4. So the numerator has been taken care of. The numerator has been taken care of. So then you go to the denominator. Denominator, you have 9.44 times 10 raised to power 2. Remember, you must express it to standard form. And then you have 1.17 times 10 raised to power 1. If you look at your table, 94 under 4, will give you 97.50. That's if you check your logarithm tables, 94 under 4, you will get 97.50. And then the first digit here is 2. Again, if you look at 11 under 7, your digit here will be 1 because the power of 10 here is 1. The power of 10 here is 2. The power of 10 here is 0. That's why this one is 0. 10 raised to power 0 is 1. 10 raised to, this one is 10 raised to power 3. 3, we'll put 3 here. Alright, so if you check 11 under 7, you will get 0.682. Again, because the multiplication sign is between both numbers, you will add it together. If you add it together, you will have 4 point, this is 0 plus 2, 2. 5 plus 8, 13, you write 3, you carry 1. 7 plus 6, 13 plus the one you're carrying, you have 14, you write 4, you carry 1. 9 plus 0, 9 plus that one becomes 10, you write 0, you carry 1. 2 plus 1 is 3, plus this one, it gives you 4. So the denominator is 4.0432. The numerator, that means the addition of the two, is 4.5965. So what then you do, since there is a division sign between the both of them, you will now subtract this from this. So you can write that one here, 4.5965, and then 4.0432. Subtract the both of them, you will get 0.5533. How did we get this? 2 from 5, 3. 3 from 6, 3. 4 from 9, 5. And then 0 from 5, 5. 4 minus 4 gives you 0. So you come and write your answer here, 0.5533. But this is not your answer. You must cross it back to numbers, because the numbers was given to, the question was given to you in numbers, not in logarithm. So you change it back using the anti-log table. For you to convert a number that is already expressed in logarithm, to convert it back to number, you look at the anti-logarithm table. Some people call it anti-logarithm, but whatever be the case, just make sure that you are looking at the anti-log table. It's just on the flip side of the logarithm table. So under that, you look at 0.55 under 3, difference 3. Again, to convert a number in logarithm back to numbers, you open your 4-figure table to the table of anti-logarithms of numbers, and then you will check 0.55 0.55, which is on this side, under 3, 0 to from 1 to 9, under 3, difference 3. If we look at that, you are sure to get 7, 4, 2, 9. But what will help you to know where to place your point is you will add whatever it is here, 0, in this case is 0, whatever it is that is here, you add 1 to it. That will help you to know how to place your number. So from here, you move the point to this place because it was already 0.7429. But because you have added 1 to 0, you add 1 to 0 to know where to place the point. And we have added 1 to 0, we got 1. So you shift the point from here and then you shift it to the front of 7. So your final answer is 7.429, which is your final answer. So if you evaluate this using the log tables, this is what you will get, 7.429. Numbers less than 1. If you're asked to evaluate numbers less than 1, numbers less than 1 are decimal numbers. All these numbers are greater than 1. Even 5.05 is greater than 1. All these ones are greater than 1. But if we are dealing with numbers that are less than 1, how do we go about it? Numbers less than 1 are decimal. They are decimal numbers of the format. The examples of such